Hey guys, it's Ben with Myers Woodshop. My buddy Mark is over, and we're going to go over this Snapmaker 3-in-1 printer. It does CNC, laser, and 3D printing. So I've had it for a while, done some stuff with it, but Mark is going to get it, and so I'm going to show you this video kind of as a, you're new to all this stuff. I got this machine, how do we make it work, and how well does it work?
And I am starting from zero.
Yeah, absolutely zero.
I have no idea what
he didn't even know what the machine was when he walked in the door. He's like, which printer is mine? So, so if you're starting from zero, this is a great way to learn what you're doing.
Baby steps.
Yeah. So this is the machine in front of us. It's the all-in-one machine, and we have all the parts that came with it. So if you're starting out, what would be your first thing if this came to you?
I mean, the first thing that I see is that everything seems to be put together in like a stupid-proof kind of way.
Yes.
So I do like that on the back here, which you can't see, but it's got the ports all very well labeled for somebody like me who would get confused really easily.
All right, so I'm going to show you real quick right here of me putting it together. I put it together myself, and it went really fast. So here's me putting it together, and we'll cut back to us talking about it. All right, so that was me putting it together. It went together really easy. This mostly you got the 3 rails, and then that control board in the back.
But it'll sit in the box all together, right?
Yeah.
With like the last thing that you used.
I put this box together last. This is an add-on for it.
Oh.
What this box does is it does have this acrylic in it, and when you're using it as a laser, this will shield your eyes. It basically works the same way as the glasses it came with, to shield your eyes from the laser burning your retina.
It looks less dorky.
Yeah. And also, when you 3D print a certain type of material, ABS, which is what Legos are made from, it needs to keep an ambient temperature around it warmer.
Like warm, okay.
A warmer temperature. So that is another reason for the box. It'll hold all that temperature in. So
and that, but that would be with the 3D printing.
When you're 3D printing that,
okay.
yeah,
okay.
yeah, because that stuff likes to peel apart when it's printing in the cold.
Gotcha.
So
yeah.
keeping that ambient temperature keeps
that
it
makes sense.
keeps it together
so
when
as
it's
long
printing.
as it's printing in that, it'll be at the temperature it needs to be.
Yes, for a certain type of temperature, and that's going to be something you're not going to do from the beginning. You're going to more than likely print with something called PLA. That's probably 95% of what everybody prints in.
We be playing.
And it doesn't need any temperature control like this. It's a lot easier to print. So this is an add-on you don't necessarily need, but I think it's like $100. But I have it, so we'll use it. But for the purpose of this video, we won't put it in here because you won't be able to see what's going on.
So real quick, things that I have learned so far already. Number one, don't touch the plate.
Yes.
You've already told me
the plate
to not do that.
For the 3D
right
printer,
here.
this thing you don't want to touch.
And then I touched it as soon as he
Said
cleaned
don't
it.
touch it.
And he had to clean it again.
Yes.
So apparently you don't do that.
No.
I guess this is where the stuff goes.
Yeah,
the
let me get some of that.
We're gonna put the play.
PLA, yeah, So it's got this holder on the back. This holder's a little weird because for some filament it's wider, like this one, and it won't go all the way on.
Well, there's a...
I added this washer. This is one downfall of this printer because every filament you buy comes, every different brand kind of comes a little differently. So this brand of PLA, it's Hatchbox. That's what I buy from Amazon. It's like $20. It's got this filament holder where it's got these ridges on the side. And this is a different brand that is a wider rung, but it doesn't have those holes.
Quick question. Surely you could have printed a bushing that goes in there.
I could have, but I had a washer on hand. So
I'm just
you can print parts for this, but yeah, when it goes in here, it's got these little screw heads, and it was getting caught.
Yeah.
So I put a washer on it just to prevent that from happening. And you see, this one fits pretty much all the way on the thing.
Not even.
Because it's thinner.
But
this
you
one,
could print a bushing to go right there
yeah.
if you want. I mean,
yeah. But that's kind of a downfall of this printer. It'll work, but it all depends on what you get.
Yeah.
So
seems like just just a sticker from one of your kids would just make that run smooth.
Either way, whatever you find is better for you. But that's one thing I found when I was printing. Initially, it got stuck, and if you're not watching it, you're screwed and your print is bad. So yeah, that's kind of what that is for. But when you put this into here, you have to take this off, and that will get mounted with these two screws on the back. Oh, so your PLA will stay outside. This
right here.
Right, yeah. And then you'll take this little piece of plastic, and it will go through this hole here.
And that's the feeder for the PLA?
You'll take the PLA that's going to be hanging off of here, and it'll go through here, and it'll just kind of angle it to make sure it goes in.
Does this mount in here somehow?
No, this is just free hanging. It goes in this hole, and it just
it doesn't like thread through the hole as the PLA
The PLA will stick through and push in. Okay. It'll stop when it'll sit right here, and it can't go any further than this.
Oh,
when it's in there.
I got you.
So that's what this little piece of plastic is.
That makes sense.
But you'll have to take off this rail in the back and attach it over here if it's going to be inside.
Okay.
So it does use these cool clips. It's like a telephone Ethernet clip to connect all the pieces, which is really nice. That definitely makes connecting wires idiot-proof. So if you've never connected or made one of these and electronic stuff scares you, this is definitely the way to go. It's the best way I've ever seen them connect things in a printer. And they're all labeled. They're labeled 1, 2, 3, 4, 5. And there's a little sheet that I taped it on the inside of this so you can know where everything goes.
What is 4? I've got 4 is empty, and you've got Z and Z for 4 and 5. What is...
we just don't use one of those. They don't use one of those.
Okay.
So, I don't remember what it is.
Easy explanation.
But yeah, we don't use one. There is one for, it's a little cable you can see right here. It's in this. You connect it so when you open the box, it'll stop the print or stop the lasering because you don't want a kid to open it up and look inside or something like that. And it connects right here with this little switch. There's a limit switch. However, the box doesn't close super nicely, and it may be because I didn't assemble it perfectly straight. I mean, it's not easy. And any little tap or something was engaging that, and I couldn't finish a print. So I'm just not plugging it in because
Okay.
that's how I've done it. It's a little downfall. I mean, it's a nice feature, but the feature didn't work very well. It stopped my prints, so I don't use it.
Yeah, that makes sense.
So the thing with this machine that makes it so special is it can do all three operations, the CNC, the laser, and the 3D printing. And that snap word, I think the way they're doing it, is essentially you snap off one of these heads that Mark grabbed, the 3D printer one is on here, and you snap on another one to change the operation.
Except it means screw.
It means screw.
It's a snap to switch it out.
It's not really a snap. It's got 4 screws on the back here. 1, 2 on the top, and then 2 on the bottom. And you can't just physically push this. We don't have it plugged in. So you need an Allen key.
Okay. Looks like almost everything is Allen.
Everything is Allen.
Which is my favorite. And by that I mean...
Everything's an Allen key, so you're going to do an Allen on the back of here.
Very much everything's in the way, it looks like.
Yeah, this is not...
swapping one out or no?
We're just going to show how you swap one out for now.
Okay.
This is not the easiest thing to swap in between. It's kind of...
But it makes sense that it would need to be pretty firm, or it needs to be stable.
Yeah.
When it's on there, so...
It would have been nicer if it was like something you can screw in with your fingers. If it had like a big head to where you can screw it in with your fingers, and you didn't need this Allen.
Oh, those are little screws though.
They're tiny. Good. They're short, yeah, it's not holding much. So if you're expecting to go back and forth between the two really fast, it's not going to happen.
I was thinking that like this is one of those deals where you figure out what CNC stuff you want to make and you make it all while you have the CNC deal on.
Ideally, yeah, for sure.
Here, we can just like push it that way, right?
Yeah, push it that way. No.
We cannot push it that way. Or maybe this way?
Yeah, that'll work.
Okay.
Yes. Move it over so the big rail isn't in your way, and that'll make things much faster.
Yeah, okay. Manual stuff, I can do.
Okay.
There's one more.
Oh. Okay, so that's what it looks like taking them off. There are 4 screws. That's the 3D print head. You can tell it says it on the front, 3D print head.
What's this button? Oh, load the filament. Got it.
Yes.
It says, like everything is nicely labeled.
It's nicely labeled. It feels high quality to the touch. It's all aluminum.
It's like thick aluminum.
Yeah.
It's not light.
So the only other thing we need to change from going from 3D printing to either of the 2 operations is a different bed.
Oh.
So right now we have the 3D print bed on there, and I have changed the factory build tack on it. It looks like this. It's got kind of like a texture on it. The stuff doesn't stick very well to this, the filament. It kept coming off. A lot of people put blue tape down or do a glue stick, and that's just a mess and it sucks. So what I've done is I ripped it off and I replaced it with a PEI sheet. That's what I have on my expensive Prusa printer. That's what it comes with, and it sticks way better. So it's like 14 bucks, and it's the best 14 bucks you'll spend. I don't want to mess with a glue stick or anything like that. So on the back of this, the bed for the 3D printing, which is hard to show, it's got another cable here, because this bed will get hot and it needs to have the power source for it. So that's that cable. You'll disconnect that.
A fan under there, or no?
No, no fan. But on the underneath side, you see there's these. This is what's nice about the bed, and I think they should have done to the heat in the ends. It's a screw where you can do it with your fingers. So you take off all 4 of these. You do want to be careful with this bed because there is electronics in it. So this bed, you can see, has you don't want to touch this. If you do touch it, you want to wipe off with isopropyl alcohol. And on the bottom, it's got this black stuff that has wires going through that heats it up, and then it has the jack for the heating element. So that's a 3D bed. Now this other bed that we have, it's metal. That is for lasering and it's for CNC stuff.
So does it matter?
It goes on the exact same way.
Does it matter what holes get?
Yes, there are 4. I think it's these 4, or maybe those 4.
What are the others for?
Those are there. It's got a bunch of holes. You can see. So 4 of them are made to connect to this sliding rail, and the other ones are for clamps. We have it comes with some bolts and clamps, and that way you can hold things down.
Yeah, you said.
And I put that. Yeah.
Oh, this is gonna be good. Yeah, there we go.
They're real tiny. They look funky. You show those off.
Yeah. So you would just put two deals to like secure the corner of something.
Yeah, you're securing corners. Yep,
yeah,
exactly.
That makes sense.
So that's what that's for.
And that's so that when the CNC is operating, it's not.
So a 3D printer doesn't need
thing's
clamps
not gonna
because it's heating onto it and sticks on it. But a CNC, if you're going to get a piece of wood,
which is essentially a router.
Yeah.
Right. And there's no blades here, right? Yeah.
Yeah, it comes with some. I just don't have them out here.
Okay.
So to attach this piece of wood, if you want to carve in your name or something, there's nothing to hold it there. So you need a clamp, maybe on one end like this or something, to hold it on when you're carving on it. So.
Gotcha.
So yeah, we'll just attach this. The bottom bed plate goes really well.
Quick question: Is there a way to clamp where you know that the machine's not going to bump into your clamp while it's CNCing?
Yeah, there is, and I will show you that method. I use that method for my big CNC, and it works really well. You put on some blue tape onto here, and then blue tape on the piece you're cutting, and then you put super glue in between, and it'll hold it. Doesn't sound like it would hold it, but it holds it really well.
Oh,
so
I see.
You're
so
super
you don't have to use clamps.
Yeah, it's a different kind of clamp, and it would be more ideal for this because you don't have much room.
You want me to?
But see, you're definitely not changing this head out if it's inside here.
Yeah. Oh, you broke it.
It's still not super easy to change these out. This is nice with the screen does come off and it's connected like this. It is a touch screen, and then it magnets to this front piece. So that changed the bed. Now we have the bed for the CNC and the 3D printer. And now we need to put on whichever head we're gonna. Let's use the laser head. We'll start lasering first.
Cool.
So it lines up. It's got 8 holes in the back, but you're only going to use 4 of them. So they are coming out with a version 2. It's I think it comes in 3 sizes.
What is it that you do?
One is
number 2.
A lot bigger than this one. So we'll see if they change out how you snap it on. I think it's probably still the same, but it would be nice again if it was a snap rather than this Allen key. Okay. Now we're not going to be using this cable because this cable is only to connect to the heated bed. So we could just leave it dangle in the back, or we can disconnect that, and that's port 6.
Are those cables the same kind of cables? This is a different type of cable right here, but these are all the same?
They're all pretty much the same, yeah.
Okay.
This one's more like a telephone size, and this one is a little bit bigger.
I knew that was like an Ethernet.
But it won't fit in there.
But that's not telephone, because that's a 6-pin. Telephone's only 4-pin.
Well, it's RJ45 is what this is.
Oh. This one's not?
Or no, I'm sorry. The top one's RJ45. This is like RJ40 or something.
Yeah, this is an 8-pin. So what are these? 6-pin.
They're telephone size.
Okay.
Or what used to be telephone, I don't know. So that's it. Now we've changed out to the laser. So for lasering, we don't have to worry so much about the material moving because nothing's touching it. We just need to get it to stick here. So we can use a clamp. So what we're going to do is do the way that we can do some CNC stuff. So get some blue tape, take your material off.
And there's no issue with touching this one?
No, right. No issue with touching this one. Doesn't matter.
Okay.
My blue tape ability is poor.
Looking good, buddy.
And if you want to blue tape the bottom of that piece of wood.
Oh. Okay. Now I understand it all.
Yeah.
Love it when a plan comes together.
Okay. So we blue tape the bottom of our material and the top of our bed. So we're going to get some CA glue. It's like cryoethylene, something like that. and we're gonna smear some of it
on a smear
to our material.
Is that
on the blue?
Gorilla?
No, it's Type Bond.
Oh.
And then we're gonna put it onto there, and you're gonna try to put it as square as you can with your eyes. This is where, if you're doing this, you want it to be square on there, because however you put it on, it's gonna stick. So if you put it on kind of sideways, your design isn't gonna come out perfectly. Okay, so when you're 3D printing, usually 3D printing takes a lot longer than CNCing or lasering. And you don't want to be connected to your computer the whole time, especially if that's your only one. Because if you want to use your computer 5 hours later and still printing, you're stuck tethered to it, plugged in. Gotcha. It does come with a USB cord to connect from the machine to your computer. When you're lasering or you're CNCing, you have to use the cord and connect it.
To the computer? To
the computer. Oh. If you're doing 3D printing, it comes with this, it looks like a whistle, but it comes with a 8 gig SD card, and on the side of it, we have a USB, a regular USB plug, and a computer USB plug.
Gotcha.
So you can do it either way. You can 3D print while it's connected too, but I mean, you want to put your files on this and let it print standalone, and it'll plug in like that. So right now we're going to install the Snapmaker program for laser and CNC and 3D printing. We're going to do that to his computer. We'll come back and we'll show you lasering. I'm not going to show you the program. You can download it yourself for free and try it out before you even have a machine. Snapmakerjs, I think. I don't know why or what that stands for, but you can go to their website and download it and try it out. But we're going to install it, and we'll come back and we'll show you how the laser works. All right, we're back. We have our glasses. We're ready to laser. You can look up all the software and how it works with their online user manual at snapmaker.com. And we think we figured out what we're going to do. We're going to laser his name onto this piece of MDF. So we have all that part ready, and I'm not going to show you that because it takes a little bit of time and it's boring. But
although, for time-wise, you had to relearn how to do it almost from scratch, and it took maybe 15 minutes.
It took 15 minutes to learn, yes.
It's not complicated.
It's not too complicated, especially with their guide, walks you through how to do it. So basically you found the focal length, how far away we would need to be from the top of the piece of wood, and we set our origin to the bottom left corner, and we're just going to laser on a name. Setting the right settings for how powerful the laser, that's just trial and error. You might have a few pieces of this material you're going to laser to try it out. Once you find the number, write it down so you remember. So we're just doing MDF. So I'm going to bring the camera in close. We're going to click Upload G-Code, and we'll watch it laser. All right, you can see it's starting to we're just doing an outline of this. And in MDF, it comes out pretty well. And this is where you would want to put this in the machine if you had a bunch of people that didn't have glasses looking at it. Because they'd burn their retinas.
I see. So it's not necessarily that it has to be in the machine.
Doesn't have to be in the machine.
It's just for,
you just want to prevent
for safeties.
Yeah, anybody's eyes from looking at the letters.
Now you said something like this won't go in there with this sticking out?
No, it will, but you can't put the PLA. That's if you're 3D printing.
Gotcha. You can't put the whole spool on.
Can't fit the spool in there. Right.
Okay. But while it's lasering, this doesn't have to come off.
No.
Okay. This doesn't clip in there or anything. It just sets in.
It just rests in the box. So we're doing 40% power.
And we're connected via
USB right now.
But did you just discover that you could do laser off of the?
We can do laser off of a USB cord.
Off the USB.
Yeah.
Drive?
I think it might just be the CNC, or it could have been updated since I last used it, and it might let you do the CNC as well. But this doesn't take very long.
Yeah, it's going pretty quick. Got some interesting sounds coming out of there.
Yep. This is an all screw-driven machine. A lot of machines are driven with belts, and the screws are by far superior. So it should give you a cleaner curve than a belt. And to our eyes, it's probably very small. And the screws are actually in the rails.
Now, how, like, if we had turned the power up to 90, what would have happened?
It wouldn't go any faster. It would be deeper and darker.
Okay.
So
would
the
it be like wood burning, like out like that, or would it just be a deep?
It'd probably be a wider.
It would be a wider thing.
Probably, because your speed isn't going any faster. Usually, if you turn the power up, you want to turn the speed up a little bit too. So it's cutting back on how deep and wide it's going to go.
Is there any chance that the wood catches on fire from laser?
Yeah, if you go too slow and your power is too fast,
Power's too high.
Power's too high and your speed is too slow, it could catch on fire. Yeah. So you never ever laser without being around it.
Okay.
Because this is the one thing that will burn your house down for sure.
Good to know.
But once it's starting, we know we're good. There's no smoke or anything. So I would say if you're seeing smoke, you're probably going too slow or your power is too high.
But in this case, you cannot change on the fly. Like you'd have to shut the thing down and
we'd have to stop it, start over, and that would suck in the middle of your lasering because half of it would be dark and you'd have to run it at that same beginning point.
Well, I mean, what you'd really want to do if you're doing a project that matters is just pull that block of wood off, put a whole new block of wood on, recalibrate from the beginning, and know that you need a weaker laser or faster speed.
Almost always when I laser something, no matter what machine, I have at least one other same material item to test. Even if it's not the full design, it's just, a line or 3 lines. I'll test what power will give me the best result. So like we're doing MDF right now, this seems to look really good to me. And the power is good. We're just marking on it and not actually engraving in it, which is the result we wanted right now. I would write these settings down for next time. So I know if MDF has worked well at this setting, next time I don't have to laser something again. Unless I'm doing something that's really expensive and it's for a customer, I definitely want to make sure that I'm right, so I would always do a sample piece.
It sounds like I want to have a notebook.
I literally have a notebook in my hands, which the camera can't see because it's aiming down at the laser, but I have written down
the field book.
The material. There's MDF, acrylic, plastic cases.
Gotcha.
Quartz.
Gotcha.
For my bigger laser.
Cool.
So
now, is this engraving?
It's finished. We have finished.
Okay.
And it looks really good. Let me get the camera in close so we can see what it looks like. So here's our outlook. And we moved it all the way to the front. So that's what it looks like with our laser. Came out really good. So we're gonna just use the same material here and CNC right on top of that, so we don't have to go through the marking on that.
All right, so now I'm gonna go ahead and swap out the laser thing.
So always turn it off before you swap anything out because we don't want it to move and crush your fingers. Eesh. So we're gonna keep the bottom base plate with our wood on there. Typically you change that out, but we're just going to save time and keep that on, and we're just going to change the end with the CNC bit.
So do you want to go ahead and put a CNC bit on here before putting it on?
Yeah, we can do that, yeah. It comes with 2 different bits. So we have, they're really tiny. One is a pointy bit, that's going to be for your engraving. I mean, it's super tiny. And the other one is a flat bit. That's going to be for like digging a channel or something like that.
You got the little, this would be a tiny Allen.
Yeah.
And you just know which one it is.
Oh, that's the tiniest one I got. Is that right?
Yep.
You want to make sure that's good and snug in there.
Okay.
I mean, it's because if it comes loose, then it shoots us like a bullet.
That does seem...
How deep did you go in there?
All the way.
Oh, there's a bottom to it.
Yeah.
Okay, good. Not all CNCs are like that, so that's great.
Let me double check. Yeah, there's a bottom.
Good.
Well, we just set the work origin, which was basically, establishing telling the machine where the surface of this was, and then we set the jog, which is basically when it raises up and moves to the next letter. That's how high it's going to raise up, so it's just barely above the work origin.
That's the retract height. You don't want it to be 0 because it'll just drag right across the top of the machine. It kind of is set up there in normally. It was set up at 0.02, which is really close. That's more closer than I want to be.
Yeah.
But the website will literally walk you through this step by step. The online tutorial. It's super simple to follow through. So we set our bottom corner. The machine knows where it is and knows where the workpiece is. So we're going to turn on the machine and start carving.
But this one is more important that we get all that stuff right, because you break your bit, like there is stuff that breaks if you don't get that part right.
CNC part is the most important part to make sure everything is right, which would be really funny if it broke right now because I said it wrong. But yeah, most important, because the laser, you can't run into things.
Right.
But the CNC, these little bits that it uses is tiny. So as soon as you bump anything wrong or set something wrong, it's snapping and you're gonna have to buy another one. So I've actually never CNC'd on this, so we're gonna see how it goes. I have a little bit of knowledge on the CNC, but not on this machine.
So we'll see the CNC for the first time.
Yes, this is it. So I'm gonna bring the camera in, we're gonna watch it cut, and hopefully it'll turn out right. All right, we're finished. It auto shuts off. Okay, so that's what it looks like.
There wasn't enough space in the middle of the bubble of the letter to retain any of the middle.
We lost the insides because we did around the outside, but it ripped it out because it's MDF. But that's not a property of this machine, it's just a property of the MDF. But you can see how deep we went. It's really clean. It came out really well. Okay, the first thing I would probably do with this is deal with the bit, because we don't want to accidentally pull this off and ram into the bit and snap it. So you want to take the bit out.
Okay.
And we want to make sure we're turned off. I'm just going to unplug it to make sure it doesn't turn on, because that will take your finger off.
Yeah, probably. Oh, okay. I'll just leave that the way it is. It'll apparently go all the way in. Where's the lid?
It's inside.
There was a blue one. Oh, no, it was black. Never mind.
So now we'll just pull it off. The paper comes off like that. And then we're just going to peel off the tape. And that was our clamp. And there's our board. So that's a really nice way to clamp things. Because we don't damage it with a clamp. We don't have to worry about hitting anything with a clamp. So
I like that.
There is our laser and CNC.
Cool.
All right, we just finished up CNCing this piece of MDF we had. Came out pretty good. And now we're going to do the last feature, which is 3D printing. So of course we got to turn it off. I'm going to unplug it just to make sure that nothing turns on and gets us. So Mark's going to take this screwdriver it comes with that we couldn't find before. It makes taking these screws in the back off a whole lot easier.
Yeah, a little bit. Those Allen wrenches are so awesome.
Yes.
I can go ahead and...
Yep. So we're going to use the last printing head, the 3D printer head. And we just got to pop off the 4 screws in the back. And we are going to have to switch back to the 3D printing bed. Again, you don't want to touch the printing surface if you can help it.
But we are plugging that in.
And that one does get plugged in because the bed gets hot, so it needs a power source. So the CNC and the laser bed does not plug into anything, it's just a platform. But the 3D printing bed does get plugged in.
That's how they do it in the pros.
Yep. So for this, we can either use the Snapmaker software plugged in via USB, or this time we're just going to use off the USB stick and use the front screen to control it. Because normally when you're doing 3D printing, the CNC and the laser was pretty quick, like 5 minutes or so, 5-10 minutes. But sometimes when you 3D print, you can go into hours. And we don't want to be tethered necessarily to the computer if that's your only computer you use, and be stuck with it. So we're going to do it off the USB stick this time.
Oh, and this manually did. Now, do I want this facing back? Or
yeah, there's an Ethernet port, well, like a phone jack. You want to face it towards the back where all the cables are. We are going to use the filament that I purchased because it does come with a filament. Every printer basically comes with some sample filament. It's all garbage. Throw it all away. This is something I purchased on Amazon. It's called Hatchbox. I think it's the best deal for the quality. This is $20 a roll, and it'll last you like 1,000 prints.
Wow.
So yeah,
really?
It just depends on how big you're printing, but we got a small bed. We're not printing a lot of things really big, so it's going to last you a long time. So we are going to stick it to where the filament rolls out this way, because it's going to come off and go into this little hole right
like
here.
The correct placement for toilet paper.
Right. Yeah, exactly. Yep. Okay. So we're going to clip the end of that first. I have a little snipper.
Don't we need that?
No, we use that clear plastic to guide it through here. We don't need it on the outside. So when you cut this filament, you want to cut it at a 45. And that makes it a tinier tip, so when we're shoving it through this hole, it'll be a lot easier to come all the way out. So for right now, we're just going to place it kind of there.
So size matters.
Yep.
But not the way you would think.
So the way we're going to put it through is we're going to turn it on first with the switch in the back here.
Okay.
And to be able to shove it through, we have to get this hot first. So we're going to plug it in to the power, I guess, first. That will help.
Little known fact.
Now we hear the fan on the back.
It takes power.
Yes. So we got to get it hot first up here, and because you can't shove it through because the nozzle is tinier than the actual filament. So we got to get it hot to melt it actually through. So we're going to use the screen on the front.
It's a glue gun.
It is it's basically a glue gun. Yeah. So we're going to use the screen on the front to turn that hot. So I'm going to bring the camera in so we can see the screen.
What are these numbers here?
So we got numbers in the front, and everything in 3D World likes to use Celsius.
Okay.
So we're at 23 degrees Celsius is the temperature of this, and the number after the backslash is our target number of heat.
Gotcha.
Right now we have nothing loaded, so our target is 0. But it'll never reach 0. It's at an ambient temperature of 23 degrees Celsius. That's like 60-some degrees Fahrenheit. Our heated bed is exactly the same. It's 22, and our number to reach is 0. Elapsed time, this is how long the print will take. And then we have a progress bar right here that will fill up, and we're at 0%. So we have a stop of the printer. If it was printing, this would be lit up blue, and we could touch it and it would stop the print. We have files. So if we click that, it'll show all the files on our USB drive that's plugged in that it comes with. And I do have a calibration cube. That's going to be perfect for test print. So I've already sliced this using the software and loaded it onto this drive. So we'll practice that. It's a tiny print. It'll go pretty quick. So we have back, home, previous, next. So we could fill up this drive to where the screen would be so full that we'd have to hit next to see more files. So once you print something, it'll keep that file on here. So you can just click over and over.
The file format that this uses is G-code?
G-code, yep. Most things, like my laser, my CNC machine, the big stuff, most things are using G-code, and that's just a bunch of numbers and letters telling all the parts where and how to move.
And you said that's not just for 3D printing, that's for
CNC
and everything?
Laser, CNC, yeah. A lot of things use G-code. I think everything that I have in my shop is using G-code. Okay, the next thing is controls. If we hit that, we can now move things around. So we have change filament, which is what we need to do because we have no filament in there. We're going to hit that first. I'm going to click change filament. It's going to say change the filament, confirm or back. I will hit confirm. And now our target temperature is 200. We were at 24. Current temp is 27. We can change the temperature up and down plus 10 if we wanted, but we're going to go to 200. That's what a lot of this PLA likes to be at, 200. It's pretty standard.
Okay.
So right now it's just heating it up, and we just have to wait until our current temp reaches the target temp.
That's very hot.
It is very hot, yeah.
Like, that's like double boiling, isn't it?
And when you touch it, it will burn your finger. So right now it's just heating up the hot end up here. It's not heating up the bed.
Right.
The hot end will get hotter a lot faster than the bed will.
Oh.
Because there's only a little bit of area it's heating up here, and it's got to heat up this whole flat area down here.
But this doesn't have to get up to 200 Celsius, right?
This will go to about 60 to max maybe 100.
Okay.
So it's a lot less, but...
Because if it went to 200, it would just melt the filament again.
Mm-hmm.
Yeah.
So we're finished here. We've reached the target temp. We went up to 210, and now it's kind of it's regulating itself back to 200. So it should say stop at about 200. And now it's going down. So it's regulating itself back and forth. But this is where we're going to use this big button in the front. So this is a button you press. It clips in here, and that just makes the gears inside spread apart. They're kind of sprung together. And when you push that, it'll spread it apart so you can stick it between the gears that turn, that pushes this filament up and down. Yeah, exactly.
So just this is hot.
Just the tip and inside in here. Yeah, no, you can touch anything up here. It is like a case around what's there. See, I made it a lot straighter, so that should make it a lot easier to go through. And there we go. You can see I'm pushing it out. And apparently I used blue last time. So you want to push out as much as you can until it comes out pretty pure white, whatever's coming out. So I'm still holding this button in as I'm pushing.
And you're not...
And then I'm done.
You're specifically doing this step before you heat this up, because with all this pushing out, would that start sticking to this?
It wouldn't matter. It's just, it knows that to change the filament, the only thing it needs to get hot is up here. And that's the selection I chose. So if you're already, let's say we printed in white, and we put it away, and we left it just like this, we wouldn't have to do change filament, because it's already loaded.
Right.
But the last time we used blue, and we want to print in white, so we want to change the filament. Anytime you change a color, you're going to have to change the filament. It's also not very good to store this filament out in the open, because it absorbs water and the moisture in the air, and that changes the diameter of the filament, and we're talking 0.02 millimeters. So, and that will, as it comes through and gets heated up, it'll change the properties of it coming out. So the drier you can keep this, I keep this in a Tupperware box with a bunch of those silica packets, so it keeps the moisture out of the air. So this is as dry as it can be, so it's more exact when it comes out. So,
does this ever have any, like right now you see that this is coming off the roll? Does this ever have, and as we touch it, it's getting worse?
Yeah. It can catch itself sometimes.
I mean, you have that washer to keep it from catching on the...
I do now. It will be tight. It'll keep itself tight as it prints. Okay. Yeah. But right now it likes to spring around. So. Yeah. So anyways, we'll go back right now, and we can go to Jog Mode, and this will allow us to move things around. You can see if I do X minus, X plus will go to the right, X minus will go to the left, Y plus will go to the front, minus, and then Z is this going up and down. Up here you can see I have move 0.1, I have move 1 and move 10. So if I chose move 0.1, it will move a lot smaller. And then move 0.0 is almost to where you can't see it moving at all. So it just depends on how exact we need to get. At some point we're going to be able to not move any more further.
Okay. But that doesn't really matter right now, right?
Not right now, no. Just to move it out of the way if you need to. The only thing left in control home is home axes. So if we hit that, it's going to find its limits, and it's going to home it to the bottom left. That's its starting point.
And you do have to do this before you?
It will all, yeah. The file may automatically do that. The file will probably automatically home it down in the bottom left. I'm 99% sure. But if we wanted to know where home was, this will be it. It has to do this first every time.
Could this get messed up? Is there some aspect, like right now it's not on the corner.
Right.
So
no.
Could there be an aspect of like, oh, I installed this plate, shifted over or something like that? And...
Yes, and that's when you're going to have to calibrate how close the tip gets to this right here. So now that we're ready to print, we'll look at settings. This is the last thing we have. We have calibration. So this will set our home point and how far away we are from the bed. Our FAC and our about, we can see the material, the layer resolution, everything, how hot, and the firmware version we're at. So right now we're going to print, and we're going to print the file I've already sliced. So we'll click on Files. We have the XYZ cube. We'll push that. It'll say Start Processing. Again, we can take this off and control it anywhere we want if we needed to for some reason. We'll hit Start. And now it's got heated bed 25/65. So the bed is going to go to 65. And once it's reached that temperature on the bed, it's going to change the nozzle to a certain temperature. We have to wait till the bed gets to that point.
Did the nozzle just drop down the 48 degrees?
Yes, the only time we heated it up to change the filament, and as soon as we came back out, it turned it off. Okay. So it's going back to the ambient room temperature, which is like 26
and that dropped
or something.
Like super fast.
Yeah, it cools off pretty fast. But it's got a fan on the side to regulate the temperature that's inside. It also has a fan underneath it that blows on the part. So as you melt the plastic, as soon as it comes out, you want it to get as cold as you can to firm up.
Right.
So it's got a fan underneath blowing down on that as well. So now it's just a waiting game.
It definitely takes longer for the pad to heat up.
The bed takes way longer than the hot end to heat up. And this machine kind of takes a little bit longer to heat up than other machines. I don't know if it's not just pulling enough power or what, but the bed takes by far the longest time. But at this point, if you're basically finished until you come back and it's printed, whatever item it is. You don't have to watch it anymore.
Like you've already loaded the file.
I loaded the file. I've done that off screen to where you haven't seen it.
Okay.
But I've created that file and put it on the SD card. So we're just clicking that file, XYZ cube, and click print.
Right now is a part of the file?
Correct, yes.
So the file itself has the temperature.
The file tells you what, yes, because we're selecting what kind of filament we're using. There's PLA, which is what we're using now. PETG gets a little bit hotter, about 20 degrees hotter.
Would the same file would...
No, you'll have to make a separate file per material.
Okay.
Yep.
That makes more sense.
Exactly.
All right.
Anytime you change any part of the material, or how much infill you're using, or how much, like how full it is on the inside, how the resizing of it, if you want it 200% of whatever, you have to make a new file.
So what happens if it's printing and the filament runs out?
On this machine, it doesn't have a monitor, so you need to know, are you going to have enough or not? Our roll is super thick, and we're printing something like a cube, like a dice. So we're going to have plenty. But on this machine, one downfall is that it doesn't have that run out. On my Prusa machine, that machine has an infrared sensor. When it's coming through and there's no more filament coming through, it'll pause the print and wait until you reload filament. This one, you're going to have to manually do that. You'll hit pause, you'll undo the filament that's in there a little bit, and then start a new roll. Yeah.
Will you be able to tell on the print where you did that?
Possibly. It'll probably have a little nub on it, a little bit of a bubbly more coming out than normal. It's best to just know I better have enough filament. When you're slicing, it will tell you how much filament you need in the program. When you're taking the file that you found online or created.
You used that word. And
I'll show you. I'll show you. It basically, you found that file, or you created a file, which is a 3D file, and you need to put it into a slicer, which Snapmaker is a part that program has a slicer there, or there's a third-party slicer. That is basically taking that file and saying, okay, this is the printer I have. Now this is how you take that file and make the printer move to make the file come out. Let me think of a better way to describe that.
Reformats it, kind of? No?
Slicing is showing you, okay, layer 1 will be a square. Layer 2 will be a square on top of that square. Layer 3 will be a square on top of that square with a little bit of squiggle inside.
Right.
So that's what it's taking, that 3D file, and saying, okay, how big is our layer? How many layers do we need? How fast can our printer move?
Based on the specifications
of this printer. Right, yeah.
Okay.
So each printer will be set in a slicer differently. Gotcha. If I took this file I made for this printer and put it in one of my other printers, it would not come out right.
Okay.
It'd be very funky. So our heated bed is at 64 of 65, and our nozzle is 228 of 225. So it's just finding its final calibration, and hopefully we're still calibrated right after moving the machine so much that it will print.
Go ahead.
So it is homing itself first. It does that every time.
So it sounds like, as far as making a file, which is a different video for sure, but I mean, creating something to be 3D printed?
Yes, totally different.
That's
much harder.
Yeah.
So it spews out a little bit of filament in the beginning.
You want to get
that will take that off so it doesn't stick to anything else.
Oh, and now it's printing.
And now it's printing our square. So I have it set to print this little brim around the outside first, just to prime the nozzle, and it'll start printing the inside part. We want to make sure the filament is flowing well before we start actually printing that first layer. And the first layer is the #1 layer that matters, because all the other layers are based upon that layer.
Right.
So if your first layer is messed up in any way, stop the print and start over.
Okay. So your foundation is just like building a house.
Exactly. So this has this, since we're printing something that's flat and square, I'm printing a little bit of extra around the outside. So if anything happens to peel off on the corners, because hot things like to peel up once they cool. So our outside will be waste. That part will peel up and not the actual square on the inside. But you can see we're at 5%, 6% done printing this. And we are not connected to the computer in any way right now. So the elapsed time, 7 minutes right now.
So does it tell you how long the print's going to take?
It does not on this screen. If you're plugged into the computer, it would in the program, but on this, it will not.
Okay.
But I'm thinking maybe 10 minutes at most for this. It's a pretty small square. I've already printed a bunch of them. This is what we're printing right here. So you can see, I'm going to show the camera. I've printed some of these before. So the white one is the one I have printed on the Snapmaker with the sample filament. The blue one is one I printed on the Snapmaker with the filament that I purchased. And you can see the Y and the X are kind of messed up.
What kind of filament?
That was the sample filament that it came with.
The stuff that it came with.
Yeah, that was stuff I bought.
You purchased, and this is worse.
Yeah, it's a little worse on that.
Like this, it's this kind of filament?
Yes. Huh. And then the Z, the black one.
So this is where the flat.
Exactly. Yeah. So you can see I cut off the flat around the outside.
Yeah. And
then the bottom is perfectly smooth and flat. And then it printed like this. So we're off a little bit on the X and the Y. And then this is one to compare to. This is what I printed on my $700 printer.
Well, this one's $800.
On the 3D printer alone, the Prusa machine.
Oh, I got you.
So this black one is a printer alone, and then the blue one was this printer itself.
So what's the, alright, so some of these, like the Y, I guess, are the Y, is the Y on the side, and that's why the grain is so much tighter, and then the Z, like you can really
the Z is on the Z is the top.
That's the top?
That's the finished layer.
And in the bottom, you can barely see that Z. That's
right.
Because it's the bottom layer.
Yeah, and also because I changed out the build plate. So normally, you have this black, this is what came with it, this black stuff, and you can see it's kind of textured. So if you print it on that, it would kind of mush into that texture, and then your bottom would be textured as well. But I took that off and used this PEI sheet because it sticks a lot better to that than this. If your printer unsticks from that, your print does, and it moves, your print is ruined.
You're done,
yeah, so getting it to stick and stay stuck is critical. And I found that this $15 upgrade has done wonders compared to this thing that it comes with. So that's why my Z is so smooth on the bottom, because it's printing on something that's basically almost like glass.
So I'm seeing this over here, like that's wrapping around and...
Yes, we are definitely going to have to adjust that.
But is that is bad?
That's bad, yeah, it'll choke around this thing.
That's what I was wondering, that's what it seemed like.
That's just the weird wrapping of this filament here.
I mean, it seems like there'd be a feeder set like up here.
This one doesn't have it.
Or up here, it'd be like a feeder right here. That would
just, there we go. Once we set it, I think it'll start pulling from here and it'll stay. Just that, it's kind of unwrapping off that first thing.
Yeah.
So. Well, yeah, 3D printing is now just a waiting game.
They just don't care about perfection the way we do.
Well, this is version 1 of the Snapmaker. Version 2 may, I think the version 2 actually has this tilted this way. So it rolls straight at it.
That makes a little bit more sense.
And if you were creative enough, or you wanted to, you could 3D print an L bracket and do that yourself.
Yeah.
Actually, it would make a lot of sense to make an L off this, so the roll aims straight at it. But unfortunately, it doesn't have it on version 1 here.
I'm a carpenter, so I just nail it in there out of wood.
There you go. Yeah, that would work. So I printed this earlier. This is a 3D printer test. Does a lot of like overhangs, how long we can print right here with nothing underneath. And I did it on my expensive printer, and then I did it on this printer. And it came out pretty well comparatively.
I'm gonna say, I mean, when I was looking at them earlier, I couldn't tell the difference.
If you look at the lettering on the front, it's kind of blurred with some stripes.
I see that a little.
This one doesn't. The overhang test, that's where it really makes a difference. You can see this is pretty jacked up here once we get to about 70, 80 degrees. And 70, 80 here is still pretty good. So we're printing at 80 degrees with nothing underneath it.
But I'm saying, like, this isn't the part you're seeing, though. You're seeing this part, and that part looks very similar.
It does.
Like, the surface looks okay. Wow.
If you're printing something, you know, if you're printing down like this, and you're going to print onto nothingness, we can print at 80 degrees pretty well, and we don't need supports. On the Snapmaker, you'll need supports underneath, which takes more time and more material. So.
I broke it.
And you broke it?
I broke it.
Well, good, because we just printed these for this.
Oh, for this video.
For this video, I literally had this printed. Mark just snapped off our little test pieces. But it did fairly well comparatively to a more expensive, dedicated 3D printer. So some other things that you can print. I'll pull this out and show you. These are some prints I've done. We have, this was a done on an Ender 3. This is a piggy bank out of white. This is called a benchy. This is what everybody prints with their new printer to test how good it is. And because there's a lot of roundness and overhangs and arches and stuff. This was not done on this printer, this was done on my Prusa printer. Then we have some dog. And the way you can test how good your printer is like the round overhangs. Down here is pretty good. And the overhang over here.
So this is clearly done on a more expensive printer.
This was done on an Ender 3. It was a $200 printer. This one came out pretty well. I just haven't printed much.
So this is a fairly high-priced printer as a 3D printer. The thing that makes it high-priced is that it does three different things.
3 different materials. It's actually I'd say a lower quality printer, but you're getting 3 different things.
Yeah. It's like everything that's multi-purpose. It could never be as good.
It's not a master of one of the things, but it multi-purposes 3 things functionally. Yeah.
That'll work.
So, and then this is made from wood filament. Literally printed wood. So, and poop. So those are some of the examples you can print on this. But let me pull the camera in so you can see. So the dice are not solid, and what you're seeing right here is called infill. So this is about 40% infill. So 40% of the inside of this 3D print is filled with PLA or plastic, the PLA. We can make it completely solid. That would be 100%. It would take a lot more time and a lot more filament. What you want to do is get the most print you can with the least amount of filament, typically. So that'll give you the speed and the savings. All right, our cube just finished. It puts it over to the side, 100%. It took 38 minutes to print this cube. So there's 2 ways to take this off. Grab it and pull, which I can't do because it's really stuck on there. You can stick your fingernail in there, but sometimes that plastic wants to jab in there, and I have bled before. And then we have a spatula over there.
Does this come with it?
That comes with it, yeah. You want to make sure that you're not poking into the plastic board. I think I should stick.
Oh!
There we go.
All right. We got a Z under there.
Well, there's our Z, and then we're going to rip that brim off because we don't want that brim. But that just helps hold it down and make sure.
It's not.
Yeah, it's filling in weird.
Not just fantastic.
It's not fantastic.
Oh, that one's
missing.
Really rough. So maybe it'd be better for this one to be to do more solid, or maybe not a 40% fill, but I mean, it looks like just the outside edge is probably too thin.
Yep.
For what it's doing, so it needs.
I think that's the quality of the printer and not so much the software, but tinkering around with the software to make it better as possible.
Well, I mean, you can tell that's like really
too thin.
So anyway, we discovered the fix to why this was choking here. We had it loaded upside down, so now it
does come from underneath up.
It's coming from underneath. Not the correct way to do toilet paper.
No.
So we're done with the print. So just turn it off, right?
Yeah, and that's it. Yeah, so now
I don't need to do anything else.
If you're going to print white next time, we're loaded. You just stick that file. You pull out the card on the outside, and you plug it in your computer. You load the file, put it in here. You turn it back on. You select the file and hit print. Cool. If you're not going to print in white, you're going to print in a different type of material, you'll need to unload the filament.
Is there something that I do? Do I need to turn something on to unload, or just rip that out?
No, you can't rip it out right now because it's in a blob on the inside. So remember when we turned it on, we clicked change filament, and the hot end got hot.
Okay.
So that has to happen. Don't ever just rip the filament out. That's bad.
Okay.
So yeah, that's pretty much the function of all of it.
Cool.
So what do you think?
I mean, it's cool. It's functional.
It's cool to do all three of these things.
Yeah, to be able to do all 3 of everything. Obviously, there's some thinking to be done as far as making, getting what you want from something that is so multi-purpose.
So something I haven't shown in this video really with you, because it goes into a lot of depth, and you can download the Snapmaker firmware and make files right now for free on their website, but their software. Their software is something left to be desired. Compared to the other software that's out there, it's not that great.
Now, why do you say that? I mean, it looked easy enough for someone like me.
It's pretty easy, but you can't go in and really change a whole lot of the expert stuff. Once you start doing a whole lot of things, you're going to be like, oh, I need to change this file and this file, and the software kind of does it funky. There's a free program called Cura. That's what a lot of 3D printers use as a slicer. It will not work for the laser and the CNC. You're going to have to use Snapmaker stuff for that. But free software called Cura, and that is much better at slicing stuff for this. I think what I did on this earlier, now that I'm remembering, is I sliced it on the blue cube with the Snapmaker program, where it left these holes and gaps, and I sliced it in Cura for this printer on the white cube, and there are no holes and gaps.
So
that's what it is. It's the software.
So it's a software problem.
It's a software problem, and it hasn't seemed to be fixed since I did that a while ago. Several months ago when I did that. So
interesting.
Yeah, so the software makes a difference. Cura is a good program and will only do slicing for it. Now, you're not going to be able to use that plugged into your computer, but really if you're 3D printing, you want to print off the USB stick anyways, because you don't want to be tethered for hours when you're printing something. So
can I use Cura with this printer?
Yeah, that's how I made this white thing with. Yes.
So how does that work?
You'll download a profile. It's basically a little file that has all the settings for this printer, and you'll load it into Cura, and when you start Cura, you'll select this printer, and then
so you change Cura to match this.
Right, yeah.
And then put it back on that.
And then you export it the same way. It's going to look very similar when you go into it, but it's just it does the magic behind it is you can see in the difference.
It's
way better.
Clearly worth doing.
Yes. So if you're going to use this, download the Snapmaker Cura profile from their forums, I think, and then just use Cura for the 3D printing. But the lasering and the CNCing worked really well with their software.
Right.
So I have all machines that are bigger, more expensive machines that do all of these things separately. They definitely do the job way better than this machine. I mean, there's no comparison. When I've spent $2,400 on a laser, I'm cutting things in 2 seconds, and this thing won't cut anything. It'll just engrave.
Right.
So it makes a difference. But yeah, can you get something that does all three and it does as good as singular? No, we're not there yet. Right. I don't know if we can be. We're waiting to see version 2. By the time this comes out, maybe you're watching this, you have version 2. It's out. If I get one, I'll show it off and see if it does any better. But the CNC works pretty well. It doesn't use standard bits. They use like 1/16 shafts, which are not very standard. Most CNCs that are hobby desktop, like my Shapeoko, uses a 1/8 or 1/4, which is much bigger.
Yeah.
More stout. And it'll cut more accurate, but we have such a small bed, we're not cutting a ton of stuff out. But you're gonna have to order some special bits. I haven't ordered any because I'm still using the 2 factory. It could be more expensive, it could be not. You're just special ordering those, so it's not as readily available. You're not running to Lowe's and buying a 16th inch shafted CNC bit, so you're going to have to have some.
Can you get any of the CNC bits at Lowe's?
You can buy a few at Lowe's. I think Freud or Diablo makes a kit, and I think Lowe's has like 2 or 3. But that's in a pinch.
Okay.
So in our small town, that's all we have.
Yeah.
Lasering, there is an add-on. This is the one that comes with the machine. They do have a separate one that, I think this is 0.04 watts. They have a separate add-on that is 1.2 watts. So it's more powerful. Okay. I still don't think you're at the power where you're cutting anything.
As opposed to that's
the one behind us is 60 watts CO2. I'm cutting up to a 1/4 inch material in one pass.
Right.
This is not, you're going to die before it cuts through anything. Engraving works great. I mean, I don't see a reason why you would upgrade to the stronger one. It may engrave a little faster. You're still not really cutting anything. I have had a 4.2 watt for my CNC. It was kind of like an add-on. It still took forever to cut anything. So if you're thinking about buying this for cutting, don't. It's not going to do it. But it'll engrave really well. Yeah. You're limited by the size of the bed. Now
with the CNC does a lot of cutting.
Yeah, your CNC is going to cut whatever your laser does.
Like notch out stuff. Where's that box that you had?
The box.
Or just scrap wood like this. If you were trying to, like, just cutting out stuff like that, you can do that with the CNC.
Right, yeah, we can cut through. This is an 1/8 inch plywood. You can cut out the profile with the CNC. Right. I did this on my CO2 laser, which took 2 seconds.
Well, yeah.
The CNC on here, well, we wouldn't be able to cut this on here because it's bigger than the bed. there's your limiting factor.
Right. And that's what I'm thinking when it comes to this machine, is the reason why you would want to upgrade from this might be detail, but probably is more going to be just you have a 5x5 area, and a 5x5 area doesn't accomplish a whole lot.
Right.
And there's no way to upgrade this to where...
Not the Snapmaker version 1 is this size and this side only. They do sell a rail up here that you can get print taller. I don't see that as something that's worth doing.
Certainly not if this is what you're trying to do.
You can't laser. You're not lasering wider. You're only printing something taller. So Snapmaker version 2 that's coming out, they are going to a more standard size bed. They have 3 different sizes. One is this size, basically. The second size is about the size of my Prusa i3. And then the third size is like a CR10 350 by 350. It's pretty big. That would be viable. But I think their pre-order pricing is like $1,600.
Right.
You're like $200-300 off buying this giant laser behind me from there. So if you're going to cut... that's tough. It's going to be different for every person what you're doing. For starting out, I have no idea how to do any of these things. I think this is pretty good. I think
it's going to be a good learning tool, and my purposes for it are very different than your purposes for it. Like these guys, you and all the other guys in the Build Guild print like toys and stuff like that, and signs and stuff, and my purposes are more industrial. I want to print parts and things that organize and stuff like that for the shop.
And a lot of those will fit that bed.
Right.
Right. Like so he was saying, his mop broke. His steam mop. The cap broke off, so we're going to design a cap, and a cap will fit on this bed, and that is perfectly functional.
Problem.
This machine is $699 right now. And
on Amazon, I just looked it up, it's $799.
$799. I think if you buy it through their website, it's $699. I think they're going to discontinue it once Snapmaker version 2 comes out, which makes sense.
Yeah.
So I think at the time when they first came out, they were like $1,200. So it's half off of whatever it came out. At $699, I'd still, if you're going to do 3D printing for like 95%, which I think you probably are, I'd go ahead and buy a Prusa.
I think I'd get something bigger.
Get something bigger. You're limited. The bed size is really what puts this down. Is unfortunate. But I don't know. Since this has come out, a lot of other Chinese companies have mimicked it now, and there are some that are cheaper, but they're not as high. This is a really high quality built machine.
It definitely feels like it is.
You feel it. Yeah. You can feel the quality, and everything snaps together really easy. It takes like 20 minutes to put together.
And I really appreciate, especially with my house and the amount of people that live in my house, like it doesn't take up a lot of space. It goes in that box, and it's a cube, not a 2x2 piece of your desk.
True.
For something that lasers and CNCs and 3D prints. So that's pretty cool.
That is a positive size about the size. You may be limited what you have size-wise, and this would fit your area perfectly. I do recommend buying this enclosure for an extra $100 if you're going to do it, because it will keep all the dust in when you're CNCing, because there is no attachment for a vacuum or anything. You're getting dust everywhere. So it'll keep that in. If you have kids and you're lasering, you do not want to look at the laser, and this is a laser protective acrylic, so you can, not everybody in the house needs glasses, and they're not going to burn their retinas.
Well, I think the biggest thing is I'm going to take it home. Excuse me. I'm going to take it home, and I'm going to start printing something, and one of the 6 kids are going to run up and
they're going to
try to play with it and like, oh, it's a cool new toy, and that's the box keeps
it's more safety for sure, and it gets hot as well, so you can easily at 200 degrees Celsius you burn in your finger for sure.
It builds character.
So that's pretty much it. Is there anything else you can think of that we did not cover or have questions about? No. So that's the Snapmaker. It's a 3-in-1 CNC laser and 3D printer, and it's about $699. Version 2 is coming out soon, but this is the enclosure that comes with it as an add-on.
And all of this stuff comes with it, correct?
All of that stuff, yeah. All of the 3 heads.
The only thing it doesn't come with it is this special mat.
Special sheet. I definitely recommend. $15 on Amazon. I'll leave a link in the description below. I I just was having a really hard time getting things to stick to this, and then a lot of people use glue sticks or blue tape, and I don't want to mess with any of that.
Yeah.
It's disgusting. So that, I mean, clearly it stuck. We could barely get it off with the spatula.
It was hard.
So it's worth $15 to buy that as an add-on.
And this would be 20.
Rolls of filament, hatchbox, again, in the link in the description. That's what I like to use, $20 on Amazon. This is gonna last you a long time.
And the only alteration you've made is dishwasher.
And I did that because of
these screws right here.
No, yeah, there are screws on the back and these little divots in here. Not everything has these. You can use a bunch of different ways to do that, but I had a washer and I threw it on. And
although the easy thing to do would be to just 3D print a bushing.
3D print a bushing, yeah. A lot of times with your 3D printer, you're going to print parts for your 3D printer.
Right.
So,
yeah,
that happens. All right, that's about it.
Awesome.
Well, thanks for watching, guys. If you like this video, make sure to hit subscribe, give a thumbs up. If you don't like this video, give a thumbs down and let me know why. So, we'll see you next time. Happy printing. So we've set it up, we think correctly.
Cut!
That's about right. Hey, it made a blooper reel. Start over.